My name is Taylor Lochran. I am the Technical Program Manager for CARMA here at Federal Highway Administration. I'm very excited to welcome you all today. We have a fun-filled presentation, and we hope to have some really interesting dialogue with you on how to get started with CARMA and your ideas on how you can become a leader in cooperative driving automation research.
And before we get started, we'll go over some housekeeping and moderating notes. We're going to have a discussions and questions portion towards the end of the webinar. So if you have any questions and you'd like to ask them, please dial into this phone number on our slide. It's also on the audio connection little tab on the top right. And that'll be displayed there, and we'll be announcing it throughout the webinar. The room number is also there, and there's a command for unmuting yourself and muting yourself, which is *#. Again, we'll remind you throughout the webinar. If any questions come up during the speakers speaking, feel free to put those in the discussion or question pod, and we can address those either at that time or at the question and discussion portion of the webinar. With that, we'd like to get to know who's in the audience. So if anyone wants to type their name into the discussion and question pod and what organization you belong to, that would be great, just so we have an understanding of who's in the room with us today. And thank you guys for being here with us today. We got a lot of you guys in the room. Awesome, and feel free to keep introducing yourselves. We're going to start with our agenda. And again, if you have any questions throughout the webinar, feel free to put those in the discussion and question pod.
So today we're going to be covering a few things. Just want to run through the agenda so you know what to expect. We're going to talk a little bit about what is CARMA and what are the components of CARMA. Our platform, our cloud, and our collaborative software that we want to walk you through. And we're going to spend some time talking a little bit especially about the software and how you can implement CARMA within your research. And then we have a lot of exciting news. We want to talk about some of the new resources for CARMA that we just kicked off in October. We want to be able to walk through how we can help you join us in this effort in understanding cooperative driving automation. So, first question is, what is CARMA? Well, CARMA is an FHWA initiative, and it's our goal to achieve the benefits of cooperative driving automation through collaboration and open source. So these are two main principles that we are trying to hold dear as we talk about and move CARMA forward, is really focusing on the open source community and what we can leverage from all the different things that are being developed by some of these developers in different spaces and how we can apply them in transportation. And collaboration is the other principle that really brings all this together. There's only so much we can do within Federal Highway in moving this, and it's really partnering with all of you out there within your research programs to bring your insight and ideas into this space. And collaboratively, we all can do this together, and that's one of the most exciting pieces of CARMA. When we talk about the CARMA research program, it falls under what we call the Cooperative Automation Research Program here at Federal Highway. Our focus is looking into how automated vehicles could work together and with roadway infrastructure so we can achieve better safety and efficiency conditions. And we've been doing this research for a long time. We've done a lot of this work looking at how we can improve fuel efficiency both at the intersections and with freight on highways with truck platooning, but also looking at how we can increase capacity on our highways as construction and widening projects become very expensive. How can we better utilize our existing infrastructure with this technology that is coming so that we can move goods and services more efficiently? So there's a lot of great opportunities we see within the industry in the advancement of this technology and our application for it within the Federal Highway Administration. So just to give a summary, if we all go back and where CARMA came from, for those of you that are very new to CARMA, it all started back in 2013 when we were looking at a research question that said, could a vehicle send a message to another vehicle, and could that message contain information so that a vehicle can optimize its control so that it could follow closer safely? And so that's where we developed a proof of concept for cooperative adaptive cruise control, which was a very successful proof of concept. And then we partnered following this project with an organization called CAMP, the Cooperative, the Collision Avoidance Metrics Partners, and they actually took this into a prototyping with a consortium of OEMs to prove out the technology and how they could deploy it in cars to improve safety on freeways with close following. And so what we learned from this project is, moving forward is that, it's very expensive to do this research. And one of the things we wanted to do was we wanted to be able to share everything we learned, especially the source code and the software. But when we did that with CARMA 1, it was kind of hard because it required a lot of proprietary tools since we were, kind of first in the space doing this type of research. And so we wanted to make two different pivot points. And one of the first pivot points led us to CARMA 2, which was the next iteration of CARMA, where we decided we wanted to make sure that everything we do moving forward was in the open source world and community. So that way, no matter what we do and what we invest in and what we develop can be shared with the community, and then you all can take it further and then apply your ideas and apply your knowledge to be able to advance this technology. And so we can get it into practice and we can get it on our roadways. And so with this CARMA 2 version, we moved in what's called ROS, Robotic Operating Software, or System, I should say. And that's really enabling us to have a lot of this automated functionality. And with that, we tried to define a method for us to combine all of our different features into one platform so that we can start to share these opportunities. And we did a successful demonstration in Virginia in 2018 on a highway working with VDOT and Transurban, partners with us at the time. And it was a very demonstratable, release of this technology where, at the end of the project, we actually released all of our open source code through GitHub. And so I think that was a major milestone in this program as we start to develop open source code. But now we're starting to release it. And the exciting piece about what we're doing now within CARMA 3 is now our whole motto has changed a little bit. We've kind of changed the motto in the fact that we want to develop in the open. So we don't want to wait 2 years to deliver our open source code and the software and all the different things we're looking at and increasing the functionality of these automation technologies, but we want to release them daily. And so that's kind of one of the biggest benefits of this opportunity for developing the open is that we can start to share and collaborate with you all along the way. So we might learn something new within our 3-week sprint cycle, and we can totally change directions. And we can start to apply what we learned, what you all are doing out in the academic community and the industry to apply better practices and to reach our goals a lot faster. And so with CARMA 3, we're also branching inside within DOT and making this a multimodal program. We're now going to be partnering with the Maritime Administration, and currently we have a great partnership with the Federal Motor Carrier Safety Administration. So as we are developing research looking at passenger vehicles, we're now going to be looking at different types of methodologies in which this technology can be applied both in freight and within ports here in the U.S. And so some of the use cases that we're focusing on within Federal Highway, we're sticking within the transportation systems management and operations categories. And so within our 6 use cases that we've awarded, the first 4 you might be familiar with, those are the 4 we started last year, looking at basic travel, traffic incident management, work zone, and weather. And this year we just awarded a new set of use cases focusing on intersections, signalized and unsignalized, as well as arterial management. As some of the newer use cases, we want to start looking at opportunities and how this technology can be used to improve safety and operations on our roadways. Our partners at FMCSA are going to be focusing on truck platooning and roadside enforcement as well as work zones. So there's a lot of parallelisms that we have within our use case that we're going to be focusing on. And our partners now here at DOT and MARAD, we're going to be looking at port drayage. And so port drayage is going to be a very exciting opportunity to see how automated trucks can really help with the movement of freight containers through the process at our ports, which are very congested today. And so we're going to really look with them and work with them on seeing how this technology can improve some of the movements of our goods. So a lot of things have changed, and changed, I say, in a way that we've awarded a lot of new work this year. And so our program has kind of grown, and it's grown in a way that we've envisioned. And our program for CARMA has grown into some different unique areas, and one of them that I really want to highlight here is what we're going to be doing within CARMA Collaborative. and support services. So those are two areas that we are developing a way to work closely with you all and collaborate along all these different platforms, but also a way to help you get started using CARMA. And we have more presentations further in the presentation to kind of explain that a little bit further. But if you look at the CARMA ecosystem here, we have our CARMA platform, which we are familiar with. It's our vehicle-based platform to help us look at some of the operational situations down to vehicle level. But CARMA Cloud is more of our infrastructure-based platform that helps us understand the different strategy rules that we want to apply to help manage those work zones and those traffic incident management situations. We're focusing on freight and ports as a major area within CARMA. And as you can look down below, we've added a new functionality called simulation. We believe simulation is a very important piece of the program because it will help us start to look at a lot of different edge cases and use cases as part of our systems engineering design, moving us closer to closed test track testing. We've made a couple of advancements in our fleet over the past year. We've now welcomed 4 new automated vehicles to our fleet here at Federal Highway Administration. Using industry's automated vehicle technology, we kind of turned to industry because we're not in the vehicle business. We're in the business to understand how we can improve the operations of our freeways. So by turning to industry, we were able to acquire the technology that they are using and then add what our open source platform enables us to do by looking at these operational conditions. And that's the CARMA platform. And CARMA platform brings in that vehicle to everything, as we call it, VX communications, to enable the machine-to-machine sharing of information so that now we can start to look at these really unique ways in which this technology can help work together and maybe drive a little bit more efficiently on the roadway. And so we are going to be soon to welcome 4 new automated trucks as our partnership with FMCSA continues to be strong. And as we welcome MARAD, we're going to have both a passenger vehicle fleet and a heavy truck fleet to help us take us into the future of this program. And we will be announcing pretty soon the first version of CARMA Cloud on GitHub. And CARMA Cloud, like I was mentioning earlier, is our way of how we're going to look at providing that interaction between the roadway infrastructure and the automated vehicle. So imagine this, if you had a way of producing a geofence around a situation like a work zone, and we want to put rules inside that work zone to identify where the lane closure is, that there's worker presence, or maybe there's a detour because the bridge is closed and we have to move traffic around. This type of information will be very useful to an automated driving system as they might update their road model, knowing what to expect before they get there. And it might help it might help that automated driving system maneuver that work zone more efficiently. And so we're looking at different types of situations in which this technology can really play a positive role in supporting automation and enabling new automation. And to kind of circle back to what I was really highlighting at the beginning of this piece is this really exciting effort we have called CARMA Collaborative. This is going to be our new way in which we're trying to introduce this conversation into industry and to develop this community of CARMA users and prospective users, folks that are interested in learning more about CARMA and how it may help them. I think CARMA is going to have the technology behind CARMA is going to have a lot of secondary effects. And so we want to be able to host those conversations and see, like, what do you see you can use this technology with and how it can help advance the things you're doing. We also want to advance our understanding about where this technology could lead in some really good, unique opportunities. And it's all about really accelerating this technology to market. Collectively, as we all do research in this area and we learn together, how can we work together to accelerate this research area and move us into the future? So we're very excited to have you here. This is just a quick overview of CARMA and where we stand. The program is growing, and we have some very exciting conversations moving forward.
And we'll pass it on to John Stark, who's on the line with us as well.
Okay, do a quick sound check. Can everybody hear me?
We can.
Okay, cool. So I'd like to spend the next few minutes just talking about a little bit about what's inside the CARMA software itself. And I've got control of the slides there. So the first thing is it's the CARMA software for the CARMA platform, which is our vehicle software. This is intended to be an extensible system that is going to give basic control functions and so forth of the vehicle so that researchers don't have to worry about all those details. and then it'll provide a standard API for researchers to build upon to study whatever particular behaviors they want to do, cooperative behaviors or even autonomous behaviors if you want to get into that. But the hope is that this is really there to set up for studying cooperative behaviors by providing things like the communication mechanisms already in place. This is the first platform that is available in the open source world to do this, that includes the V2X communications systems and the cooperative behavior fundamentals underneath. So we're pretty excited about getting everybody to join in and help us work on this. There's a lot of research to be done, a lot of room for new ideas here. As I said, the CARMA 3 software itself is going to provide a bunch of core functionality, which is connecting to the various sensors, doing the control of the vehicle, actuation of the steering, throttle, brake, so forth, providing a world model, providing a model of the vehicle dynamics, providing communications mechanisms through an onboard unit, through DSRC or cellular or whatever. Those things will all be done, and then it'll provide an API for researchers to look at the behaviors. The behaviors are going to be controlled by software plugins that can be contributed by third parties. We'll be writing a few of them ourselves, but by and large, we're hoping that the rest of the community will be contributing these to embody your new ideas here. So let me change slide. When we're talking about the vehicle behavior, we've got 4 aspects we want to look at, from left to right, going from macroscopic to microscopic, if you will. First of all is defining the route itself. This is how do I get from point A to point B, whether it be a 100-meter route or it could be 100 miles down several different roadways chained together. This is the whole mission for turning on the car, driving it, going to your destination, and then turning it off. So we have one route that's going to be defined that. It's going to be essentially most of the time loaded at the beginning of the route, and you'll drive it and you'll get off. But there's going to be opportunity to change the route in mid-course if needed. If there's, an incident pops up and a bridge is closed or whatever, we will have capabilities to handle situations like that eventually. But that's the idea with the route. The maneuvers then is the next level down. So once you have your route defined, at any point during the driving of the route, the computer is going to be occasionally looking up and saying, well, what set of maneuvers do I need to do for maybe the next 30 seconds to continue to achieve my mission to go down this route a little bit farther? This may include changing lanes to get onto an approaching exit ramp off of the highway, or to take a left turn lane at a traffic signal or something like that, or avoiding traffic and other obstacles in the roadway. So that's kind of planning at the 30-second level. General behaviors. Am I going to stay in my lane? Am I going to speed up, slow down? Do I change lanes to the left, for example, or things like that? And the next level of detail below that, then there's trajectory planning, which says for each one of these maneuvers, what exactly is my intended pathway? So I can start laying out imaginary dots along the roadway that I have to follow and say, okay, when I change lanes to the left, I'm going to be, exactly following this path here, or at least that's my intended plan. So that's looking at maybe 5 seconds into the future and planning those 5 seconds in quite a bit of detail. And at the next level below that even is the command level, where this is just motion planning that says, for the next 1/10 of a second, exactly how much angle do I have to turn into my steering wheel? How much do I have to press the brake pedal, so forth. So that's going to be changing very frequently just to make sure that we're following the planned trajectory. During the maneuver planning at the 30-second level, this may involve some negotiations or communications with other vehicles nearby, or maybe with the infrastructure to get updates on what's going on around us, and maybe working to have establish some idea of cooperative behaviors that we can do to better advance both of us or all of us to our ultimate objectives, and thereby increase the throughput efficiency of the roadway that we couldn't possibly achieve if everybody's doing things autonomously. So this slide gets into, could be a lot of detail. We're going to see some numbers here that show a general flow of control through the software here. I don't want to go through all of that, but just on the left in general, I want to show the yellow boxes are the CARMA core components, which are as provided through a normal CARMA installation. These are all of the stuff that third parties don't really have to worry about. It's just there, it's provided, it's controlling what's going on. The right-hand side, the purple boxes are the ones where the plugins live. These are the plugins that researchers can write and do whatever they want to do with, and you can have multiple plugins living in a given instance in a vehicle, and they will all be able to work together. And I'll explain a little bit of how that goes. So starting from the top, the route planner. So once we've got the route planned, we will now go into the maneuver planning. We have a component called the arbitrator. It wakes up and runs about once every second. And what it will do is we'll tickle each of the strategic planning plugins that says what the behaviors are supposed to be. And it asks all of them that are available at the time, for the given situation, give me your best plan for going forward for the next 30 seconds, or some subset of that, whatever you want to do. And each plugin, whether it be a platooning plugin or just a straight line cruising plugin or traffic signal transit plugin or whatever, they'll be able to provide, here's the kinds of maneuvers that I think I would like to see done. And then the arbitrator will have some logic in there that says, weighs each one of those based on the various merits of it, and chooses which one is the best path for the current ODD, the current situation. And it will pick one, and then it will pass it off to the plan delegator, or it will just basically put it on display there. And the plan delegator then will wake up 10 times a second and say, hey, what's the current maneuver plan? I'm going to go look at that and say, where am I in that? I'm going to look at, then I will go back and ask the strategic plugins, whichever one provided the maneuver that I'm currently executing, okay, go plan me the detailed trajectory for that. This is the 5-second look ahead, right? So we're going to get the details again from those plugins, and it may use some tactical plugins with more basic maneuvering capability to show us how to do that, such as just exiting a highway, changing a lane, doing something basic as opposed to forming a platoon. Once the trajectory is all produced, then it will send it to a validator, which makes sure everything is consistent and there's no egregious errors in the trajectory. Everything is executable according to the capabilities of our vehicle. And then it will go off and execute those using control plugins. And we have a choice of control plugins for various purposes, but those are going to be the ones that actually give the commands to the actuators to steer the vehicle, to change the throttle, to change the brake pedal, and so forth, and enable that motion to go forward. So that may be a lot of detail, but I'm trying to keep it simple, but give you a little bit of a picture of, there's a lot of opportunities in here for researchers to jump in and help out in different areas. If you have, for example, a special interest in control software, you have a better idea for an MPC controller or something different from an MPC controller, that would be a good place to contribute. If you want to do a new plugin for lane changes, or if you have some ideas on platooning or speed harmonization, or how to handle a work zone, we would welcome your inputs on how to build a plugin to do one of those things, or a set of plugins to do those, if that may be the case. Okay, Monica, I believe I'm done. Ready for the next one.
Okay, so my name is Michael McConnell. I'm a software in the CARMA program, and I'm going to be talking to you a little bit about implementing it into your own research. Okay, so first off, as Taylor mentioned previously, we have 3 components to CARMA. So The first one is our CARMA platform. And for that, at the moment, you need your own vehicle that's capable of performing an automated driving system type behavior. So you need to acquire what we call a CARMA kit. That's basically a sensor suite and control functionality that can be applied to your vehicle. So at the moment, the minimum equipment that you need is a LiDAR, a GPS, an IMU, and some kind of steering and speed controller for your vehicle. However, we also recommend for upcoming work that you also have cameras and radars on that vehicle. Now, we realize it's rather expensive to acquire your own automated vehicle at the moment, so we are working on simulation capabilities to hopefully reduce that barrier to entry for those who can't afford it. Additionally, once you have a vehicle or ready to start testing, what we have done is Dockerized our software platform. So for those who don't know what Docker is it is a system that allows you to create what's called a container for your software. So that's a closed environment that allows your software to run in isolation. And by doing this, we can redeploy CARMA more quickly onto different host PCs on vehicles or in your development environment. Once you have CARMA up and running, as John mentioned, the next step is to try and develop plugins or identify exactly how you want to implement your software into that system to do your research. Now, if you're more interested in the infrastructure side of things instead of on the vehicle, we also have our CARMA Cloud system, and we're working on integrating the communications between CARMA Cloud and CARMA together at the moment so that you can have a sort of management center type research conducted. So now for this next slide, I'm going to focus a little bit more on the CARMA platform deployment on the vehicle. So one of the challenges that we've encountered in the past is that with these really complex systems, it can be hard to redeploy the required version and also to keep your configurations and your calibration values consistent between your different hardware configurations. So what we have done is create a modular Docker system that allows us to more easily manage this, and this is the flow you would want to follow if you're using CARMA on your own system. So first up, we've got a couple different what are called Docker images or Docker containers here. So the first one is the CARMA platform. That's going to be the Docker image that's available on Docker Hub, so you can easily download it. And that contains the core software. Additionally, we have containers that run each of our drivers, and these share the same host network on the vehicle PC. And that allows them to communicate with ROS directly between the containers. We also have a web user interface, which is the UI that's used to actually control CARMA and start your experiments. Now, as I mentioned, configuration is a big part of this. So we like to separate the concept of configuration and calibration. So configuration defines the sensor set and the actual hardware models that are being used in your execution environment. So if I have a Lexus that contains a single LiDAR and a GPS and a vehicle controller, that's defining my configuration. And that is all stored in our CARMA configuration image, which can be versioned using Docker as well and easily redeployed. And then that is the component that controls which drivers are going to actually be launched and what ports they're going to be looking at runtime. Now, along with this, there's also what's called calibration. So that's the actual specific individual hardware component values that are unique to each piece of hardware that have to be tuned or calibrated on each vehicle. And we have our Docker images pointing to a folder structure on the host that contains that information. So the combination of a CARMA configuration and a vehicle calibration will allow you to have a consistent deployment without as much potential for losing your configuration on your own vehicle. Additionally, all these components are capable of logging to the host vehicle during operation. And if you look online at our GitHub repo, we have a separate repo from our main one called CARMA Config, which has examples of how these can be configured under the same GitHub organization. So with that, I think I'll pass it off to our next speaker.
Flowchart daily. Sorry for the disruptions. Microphone passing was going on our end. I am one of the many people supporting the CARMA Collaborative team with Taylor, and we have been working over the last year to cultivate a growing community of CARMA users, prospective users, and other stakeholders. We are aiming to promote the benefits of cooperative driving automation and to support different CARMA areas utilizing the resources available through the CARMA support services and other areas. We are actively working with different types of stakeholders, academia, technical industry, consultants, and public agencies. And I'm going to pass this over to Katie Blizzard, our Connected and Automated Vehicle Industry Liaison, and she will go over different engagement opportunities coming up.
Hi, this is Katie, and I just wanted to talk about how we're engaging partners across the country and how we're working to engage partners across different sectors. In the past year, we've made a push to engage academic partners, and the map shown here highlights our growing academic community and some of the leaders in cooperative automation that we're currently collaborating with. And this map is growing weekly. So gold stars here are partners that are actively working on CARMA research or working to incorporate CARMA in planned research. And blue stars are academic partners that we have started a dialogue with on how to collaborate on cooperative automated research with CARMA. In the coming year, we'll have many more engagement opportunities designed to connect with a wide variety of partners. Later this month, we'll be attending the Florida Automated Vehicle Summit in Miami. In January, we'll be exhibiting at the Consumer Electronics Show and at the TRB annual meeting. At TRB, we'll also be holding an in-person CARMA Collaborative meetup open to anyone, and we'll share more details about that opportunity. It's not working. In the coming months. Additional meetups will also be aligned with conferences over the next year, including South by Southwest in March and the SAE World Congress in April. And we'll additionally be having quarterly webinars such as this one to share sort of more broadly CARMA news and developments, and we anticipate holding the next webinar probably in early 2020. If you or your organization is interested in learning more about CARMA or participating in a one-on-one conversation with our team about how to get involved, please reach out to us, and Monica can share our contact information in the chat pod.
Hi everyone, I'm Kyle Rush, and I'd like another software developer working on CARMA, and I'd like to talk to you all today about the CARMA Support Services. CARMA Support Services are a new resource available to the public. CARMA Support Services is a help desk oriented around CARMA that will be operated from 8 to 5 p.m. Monday through Friday, which can be reached at karmasupport@dot.gov. If you reach out to us with your questions, we'll do what we can to get back to you within 24 hours with some kind of response, hopefully resolving whatever question you may have or providing with the information you seek. We are looking to provide resources and answers to questions pertaining to many of the different areas relevant to the CARMA program, including software troubleshooting, questions about system architecture, inquiries about any of our CARMA message sets, or any of the other open standards in connected driving automation, questions on cybersecurity, questions you may have about data storage and management, as well as questions about any of our documentation or tools we may provide. Throughout this process, we're also looking at proactively developing and sharing documentation on the general CARMA system, including aspects of how to install, how to operate, and any other kind of needs that one might have that we can provide documentation for. Going forward, we hope to be able to build up a knowledge base that we can make publicly available based on frequently asked questions to the CARMA Support Services Help Desk, and thusly we can provide a centralized source of information for all of your CARMA questions.
And we'll pass it back to John to just go over some of the upcoming milestones for CARMA.
Sure. So just last month we released CARMA version 3.1. So this was the first major release under the CARMA 3 nomenclature, and it was really what provided all of the dockerization that Mike was talking about earlier. So we now have a complete system that can be installed through the Docker environment. That was a major milestone for us. We've got a CARMA roadmap under development right now. This milestone chart is kind of the first peek at what that is, but we're going to be having more details show up on our GitHub website very shortly, and then we'll be updating them continuously throughout the coming couple of years. In February, so we're working right now on the CARMA core, the basic functions that I talked about, and that'll be available probably in the late February, March timeframe. We'll have the core capabilities released. We'll probably be doing a lot of system testing on it throughout March, but in that time frame, generally, it'll be available. At that time, we'll also have a simulation roadmap that will detail out exactly, for those of you who really are interested in getting into the simulation game, how we're going to be progressing along there as far as all software simulation, hardware in the loop support, and so forth. So that'll show you a lot more where we're going to be going in the next 2 years or so. In June, we will be pretty much done with our passenger car freeway use cases. So we'll have another major release there that shows all of that capability. And this will include several plugins that do various things like cooperative lane merges and so forth. In August, we'll be applying the same capabilities to freights. Well, I should say throughout the summer. It'll be done in August. So we'll have 3 new freight use cases that Taylor talked about. Those will be available in the August timeframe. And then rolling right into taking those trucks further and doing some port management use cases with the trucks. That'll be available at the end, towards the end of the year. Also along those lines, a cybersecurity plan. We will be looking at what does it take to secure connected automated vehicles from various threats. So we'll have a plan out there. We're not going to be implementing any software to support that kind of thing at this time, but this is at least a first systems engineering look at what's possible, what's required, what are the big concerns to start thinking about. And moving on into 2021, then we're going to be looking more at the arterial use cases, dealing with signalized and unsignalized intersections, and even managing the arterials in between intersections. And then we start, in IHP in August. So integrated highway prototype. That's basically showing how we have several of these various use cases I've mentioned are going to be bundled into one demonstration where we can do a whole bunch of them at the same time. And then we're going to be starting off onto a big new architectural change in September, which would be in September of 20. It'll take most of the next year to do it. That'll be a conversion to the ROS 2 framework. We're using ROS 1 right now. ROS 2 will be a next leap forward to keep up with the changing technology in that framework. So that's as far as we can see at this point, but I'm sure that's going to set the stage for a whole bunch of new exciting opportunities beyond that.
Awesome. Thank you, John. So next we're going to be having some more information here on most of these slides are shareable. You'll also be able to click them, but we will have this information in the chat box shortly. And you can always email, I put it there in the chat box, karma@dot.gov if you want to have any more information about how you can contribute to this research. If you want to set up one of these one-on-one meetings that Katie talked about earlier, you can email karma@dot.gov. We're going to go into the question and answers portion of this webinar. So you'll see here the no code just put in the chat box how you can unmute yourself. So if you want to ask a question, just dial into this number and put the conference room and you can unmute yourself. If there's any questions now, feel free to say them over the phone, or if in the chat box, you can also type in your questions. We'll give you guys a few minutes.
Sure. I see a question in the chat pod about whether or not the CARMA software is Java-based. And to that end, the CARMA 2 software is largely Java-based. In the CARMA 3 effort, we are reusing some of the Java-based components from CARMA 2. So legacy components remain Java-based, but most of our new development in CARMA 3 is focused on either developing new C++-based nodes or converting some of the legacy components from Java to C++ where necessary.
We also got a question, does CARMA vehicle models also include specific vehicle powertrain models as well?
Yeah, I'll answer that. So the vehicle modeling aspect for CARMA is something that we've only recently started getting into. At the moment, we have sort of a simplistic vehicle powertrain model. However, we're very open to contributions in that regard. So if you have expertise, we definitely would like to hear from you.
Yes. Another question. We have some, but not all the sensors from stock CARMA kit. Will it be possible to use this hardware stack by remapping the ROS topics to make it compatible?
That is also most likely true. Without you listing the specific sensors, I can't be sure. Is there someone?
So you can follow up the email address at karma@dot.gov with more information on that question you had on the sensors you have, and we can take a further look at it and get back to you with a better answer that can help you move forward on that one.
Another question, when will the simulation component be available, roughly?
So we're working together to put together an overall roadmap of our kind of simulation timeline that should be available around the February of 2020 timeframe for a better picture as far as when we'll be making deliverables on the simulation component front. Right now, there's still some decisions to be made and some paths to be chosen.
Another question coming in, if CARMA 3 is converted to C++, is it in the latest C++ 17? How CARMA implementing its decision into vehicles longitudinal and lateral control? Does it directly change ACC and steering?
Yeah. So the C++ version used in CARMA 3 is largely C++ 11. I don't think there's anything that would prevent us from upgrading language version to C++ 17. But the version of ROS we use, I believe, defaults to C++ 11, so it's what we've been using for now. As far as the decision into the vehicle's long lat control, yeah, we have a direct control loop with the lower level vehicles. There's a hardware unit that's actually directly manipulating the throttle or the servos on the steering wheel, for example, but we speak directly to that to input, I believe, either desired curvature in the case of steering or desired speed or some sort of torque-based acceleration representation for lateral or longitudinal control, sorry. But yes, we do have access to the vehicle control at that level.
Another question from Omar in the chat pod. Have one of the existing use cases of CARMA been documented so that one can learn about how CARMA was utilized in a demonstration? Very good. So again, that question was, have one of the existing cases with CARMA been documented so that one can learn about how CARMA was utilized in a demonstration? I think John is about to speak to that.
Yes, I thought I'd give it a shot. So yes, we have documented what we've done for an IHP demonstration that Taylor was mentioning, where we did some work on the highway in Virginia last year. It was a successful experiment. We've got some documentation on it. Unfortunately, I'm not the best person to say exactly how to get a hold of that document. That's a deliverable for federal government, federal highway, but it is open, and we can make it available to you. I could even take your name and figure out a way to get it to you. But that is documented, so that would be a use case with speed harmonization, platooning, and lane merge. we've all done. That was with CARMA 2 now, so depending on what kind of information you're looking for, it may or may not apply really well to how we do CARMA 3 in the future.
Thanks, John. CARMA pages, so you see the CARMA.
I think that also first one there.
Hold on, we have a loop. All right, testing. Uh-oh.
You have been muted. Your microphone has been turned on.
You guys able to hear us now?
I can hear you.
We can hear you.
Okay.
Great.
Now try.
Alrighty. So as I was saying, so we have some useful links in the useful links pod. So you'll see the CARMA website as well as the GitHub and the Confluence site, which we've been referring to during this webinar. And again, you can always email us at karma@dot.gov to get that link as well as any other questions that you have. We'll get back to the questions that we were just working on. So I have here saying one of your slides shows the state and local DOTs as potential collaborators and participants in the program. Since DOTs typically don't build vehicles or develop ADS system, what role do you envision for infrastructure owners?
All right, that's a great question. This is Taylor. So I think one of the greatest ways, one of the strategies we're looking at is how we can help support the DOTs in looking at how this technology can support, the future of TSMO in their program areas. And so, working with the state DOTs and how they can use, let's say, the universities and the partners within their state to help them move towards, those use cases. And we're going to pass this right over to Brian Cronin.
Hi, everyone. So the big issue right now we're hearing from the AV space is that dynamic traffic situations are challenging for them to operate in. So approaching a work zone, approaching an incident, approaching a traffic signal. And so when we talk about cooperative automation, which is the foundation for CARMA, it's about how do we have the infrastructure share in real-time information about these different events. So we're thinking about what a state DOT could do. One, it's provide connectivity. And two, it's provide the data that all these AVs will need. So whether that's the weather data message that the department has been working with industry on, whether that is the SPAT message, whether that is incident message. So fundamentally, the role of the state is connectivity and sharing that infrastructure information to enable these AVs to work. So in a work zone, where is your work zone? What's the speed limit? What kind of spacing you might want a platoon to operate in? When is the work zone operational? So these types of things are all described in sort of the TSMO strategy. The document that we spent the last year working on was a concept of operations for all these strategies. We engaged a lot of state DOTs and other partners in defining these use cases. And so now we're going about building them. So what Taylor was talking about is we're also trying to figure out how do we get the industry building the use case capability. And so how do we get collaborators? And so one role that we found a lot of willing partners is universities would like to innovate in this space. And there are usually state DOTs who have research dollars, who have ideas that they can provide to their local university on what is their issue. Is it work zone? Is it operating on signals? Is it incidents? Is it cyber? What are the technical challenges they may want to face? So I hope that helps kind of explain a little bit more in sort of a role. Obviously, long-term in the deployment phase, it is how do these AVs work with our infrastructure and receiving and sharing data to operate more effectively.
Another question coming in. One of the existing use cases. One of your slides covers that to effectively use the CARMA platform, a physical view equipped with sensors and devices are needed, right?
That would be correct at the moment. However, as mentioned, we are trying to build out some simulation capabilities, so that wouldn't be a hard requirement.
Another question coming in, what kind of activities do you envision taking place with the cybersecurity plan? Should we expect a specific pilot project?
So I think with the cybersecurity plan, what we're trying to do is look at what are some of the challenges is focused in the heavy trucks area for cyber. And so this effort is starting to dive into that and address that issue. And so that's the focus area for the cybersecurity effort that we mentioned in the milestone. There's a lot of other discussions that we're having, and I think CARMA is going to be a great resource and tool where we can have some of these cyber questions when we start talking about some of the issues that maybe arise with, adding communication to a system. And so I think this is the opportunity we have here in addressing cyber is looking forward into this effort.
Going back to what Brian was speaking about, why is the intersections use case separate from arterial management? Does the intersection use case relate to safety warnings at intersections?
Yeah, so I think with that arterial management, we're looking at a connected corridor and maybe even the dynamic lane assignment type configurations that are out there on the arterial side, whereas the intersection conversation, we're looking at more of a stop sign yield type approach and how the cooperative driving automation classifications can help the maneuver those unsignalized intersections with the different levels of cooperation.
Question from Faraz. Do you have an understanding of some of plug-in projects you feel they would push the CARMA project even faster?
So there's going to be, so through CARMA Collaborative, we're going to be working on describing the way we've architected our CARMA feature groups and CARMA features. So we've kind of looked at all the different features that we're developing within CARMA to help us address some of these cooperative driving automation situations or scenarios per se. And so that's going to be one of the next conversations we're going to be having within the collaborative is looking at the different features and feature groups that we're laying out kind of in a development roadmap. And it's those feature groups and features that CARMA platform enables, but also within the cloud. We're going to have features that the cloud will have to provide specific information for whatever scenario. And I think using those features will help us understand how we apply them in addressing some of these unique use cases.
And then going back to a question from...
Yes, John.
Sure. So, yeah, just to maybe get a little bit more specific on that question, if you're looking for a particular type of plugin to start writing, I might suggest cooperative ranges would be a great place to start. That's something that we're going to be developing in-house at some level, but it's deceptively difficult to do. There's a lot of different ways to approach it, and we're not going to have the time to really research all the possible ways and pick an absolute best one. We're going to take our best shot and make one that works. But I think that's an area itself that, even though it sounds like a simple type of maneuver, there's room for a lot of decisions and research on that.
And so to answer the next question there, as a follow-on question, the area really to focus in for these unique situations or features is in the strategic side. The tactical level is more basic, lane change or lane keep, just specific have a tactical maneuver. The strategic plugins are a combination of some of the tactical plugins. The strategic plugin area is where we would start looking at when you want to think about the idea of what you're trying to execute for that functionality.
So, put it this way. A strategic plugin is trying to achieve a particular goal that gets us towards our mission objective, in other words, following the route. A tactical plugin is really just there to do a specific task at the request of a strategic plugin. So it doesn't necessarily know why I'm doing a lane change. It just says, okay, I'm going to go do lane change. The strategic plugin has to have an understanding of why I'm doing what I'm supposed to be doing.
I have one more question from Ms. C, but if you have any questions, feel free to put those in the chat box. We have a few more minutes to address those. You can always email the CARMA@dot.gov email and visit some of our links that also have more contact information. This question is about the CARMA planning flow chart shown on slide 19. Is this flow chart unique to CARMA? Is there documentation for this flow chart with detailed logic?
Yeah, I can take this question. So I think there's a couple different aspects to this. Like the particular structure of this flow chart is unique to CARMA. We think it's based on a relatively common pattern in autonomous driving systems with the way the route concept flows from low specificity to high specificity in different stages. But the particular interactions with particularly the plug-in components is something that we feel is unique to CARMA and is kind of where a lot of the additional potential and capability comes from. We do have documentation for this document. It's up on our Confluence page. I believe this exact diagram is, as well as I believe we have the detailed and high-level design documents for each of the components identified, at least on the left-hand column of this. Some of the plugins are still yet to be fully specified and designed, so we may not have detailed design documents for those plugins, but for the arbitrator, plan delegator, trajectory executor, etc., we should have all that documentation available on our Confluence site.
Then going back, is there a list of unique situations that we can refer to, intersections, or something similar to that?
Yes, and I think what we're going to be publicly releasing very, very soon is the TISMO ConOps document that lays out all the different situations that we worked with our stakeholders, that we identified for work zones, weather, traffic incident management, and some basic travel situations. So that would be a great start. It's a very well organized document with lots of different areas that we need to focus on, and we just don't have all the resources to look into all of those different situations. So what we did within that group and the strategy of working with the stakeholder committees, we worked with them to identify the top situations, and those are the ones that we're building out today. So there's still a lot more work to do, and that's one of the ways in which we want to collaborate with you all, so you can kind of look into these situations and see if these are some of the areas that you can help us focus on in identifying solutions for these issues.
If we have any questions coming up in the chat pod, we can address those. Anyone else have any questions? Alrighty, if you have any questions we have someone typing in the chat box, but again, you can always reach out to us at CARMA@dot.gov, and I'll put that in the chat box again. And we have these links in the Useful Links pod where you can learn more about the work that's being done right now on the CARMA project, and you can always reach out to the CARMA@dot.gov with any more information. We also have Taylor Lockring, who is speaking today on our webinar. His information right here, which you can also email him.
Yeah, thank you all for attending. This is a very exciting day to be able to talk to you about this milestone in this program. We hope that you can join us in this effort as we start to invent and create and envision a new transportation system with this technology and how we can use it to increase our safety of our roads, improve our efficiency, and just make life great. So we really appreciate all of your attendance. We look forward to the future partnerships with each and every one of you. And feel free to reach out to us. We're here to help. So thank you so much for your time today.